I'm Tim. This PCB Sync.
When it comes to choosing high-frequency materials, Rogers' RO4350B is a classic option that's often mentioned. In this video, we'll take a few minutes to clearly explain what RO4350B actually is, its key parameters, what applications it's suitable for, and what you need to pay attention to during design and manufacturing. RO4350B is part of the RO4000 series and is a glass fiber reinforced composite laminate made of hydrocarbon and ceramic materials. It's not your typical FR4, nor is it a PTFE material. Its main feature is that it strikes a balance between high-frequency electrical performance, manufacturability, and cost, and it can be processed using methods similar to those used for epoxy glass fiber materials. Compared to some PTFE microwave materials, it usually doesn't require special via processing procedures. Let's take a look at its datasheet. First, let's look at the important electrical parameters. RO4350B is in this column, and its dielectric constant is 3.48, with a tolerance of plus or minus 0.05. However, for transmission lines, electrical length, and electromagnetic simulation, Rogers also provides a design dielectric constant of 3.66. At 10 GHz and 23 degrees Celsius, its loss factor is 0.0037. Also, pay special attention to the note below. There's an exception. For 4 mil thick RO4350B, the dielectric constant is 3.33 with a tolerance of plus or minus 0.05. So before designing, you must confirm the specific thickness and the corresponding application data. Let's take a look at the circuit diagram. This is an example of a 5.8 GHz open source distributed phase shifter. J2 is the input terminal, J1 is the output terminal, and J3 is used for bias control. The TL1 to TL4 in the middle are transmission line structures, which, together with the diode components and matching elements, achieve different phase states. In high-frequency circuits like this, the PCB traces themselves are part of the circuit. The width and length of the traces, dielectric thickness, copper thickness, and the material's decay all work together to affect impedance, propagation speed, and electrical length. If you switch the original material to RO4350B, the decay of the design changes. Even if the shape of the copper traces stays exactly the same, the impedance and phase may still change. So when changing the board material, you can't just swap out the material name. You also need to recalculate the stack up, trace width, and transmission line length. Now let's continue looking at the datasheet. Besides DK and DF, you also need to pay attention to thermal performance and certifications. The z-axis coefficient of thermal expansion for RO4350B is 32 parts per million per degree Celsius. Its TG is greater than 280 degrees Celsius, the typical TD is 390 degrees Celsius, and the thermal conductivity is 0.69 watts per meter Kelvin. Another very important feature of RO4350B is that the material meets the UL94V0 flammability rating. For communication, industrial, and commercial products that require flame retardant certification, this factor often directly affects material selection. RO4350B is commonly used in base stations, power amplifiers, base station antennas, RF front ends, filters, power dividers, and other microwave circuits. It is not the default answer for all high-frequency projects. If your project focuses on low loss, controlled impedance, batch consistency, and also needs to meet the UL94V0 flammability rating, then RO4350B is usually worth prioritizing for evaluation. Ultimately, you still need to make a comprehensive judgment based on factors like operating frequency, board thickness, copper foil, insertion loss, impedance tolerance, and cost. When it comes to processing, we can refer to this processing manual. RO4350B can use many production processes similar to those for FR4. The Rogers processing guide states that it is compatible with common FR4 processes, such as developing, etching, and desmearing. Before metallization, it doesn't require any special treatment and is compatible with both electroless copper and direct metallization processes. However, this doesn't mean you can completely copy the FR4 production process. In actual production, you still need to reconfirm drilling, lamination, etching, compensation, and surface treatment based on the board thickness, copper thickness, hole diameter, stack up, and impedance requirements. So, to sum up, RO4350B is a compatible, high-performance, manufacturable, and flame-retardant certified material from the RO4000 series. Its key features include controlled decay, low DF, processing methods similar to FR4, and a UL94V0 flame-retardant rating. If you're designing an RO4350B high-frequency PCB, PCBCanic can assist you with material recommendations, stack-up evaluation, impedance calculation, DFM review, prototyping, and mass production. Scan the QR code in the image and upload your Gerber files to start your inquiry. If you found this content helpful, please like and subscribe.